Welcome to the first video for the lesson, A Skewed Reality, Determining the Better Measure of Center and Spread for a Data Set. This lesson falls under the broader topic of one variable statistics. You all have been collecting and organizing data for years now. You're also familiar with various data displays such as dot plots, stem and leaf plots, histograms, and box and whisker plots. In this lesson, we are going to explore how we can describe the shape of a data set, whether it is skewed or symmetric, and also how we can determine whether it is best to use the mean or the median in order to describe the measure of center for a particular set of data. So to get started, let's quickly review mean and median. Mean is the average of a set of data. So that is when we find the sum of all of the terms within our data set and divide by the number of terms included in that set. So taking a look at this formula, we have the mean, and the way that we would say that there is X bar. So the mean is equal to the sum of the data divided by the number of terms in the set. The median is where we are finding the number in the middle. So when our data is organized from least to greatest, we're starting on the outside, working our way until we find the number in the middle. So for this first set of data, we can see that 9 is our median. That's in the middle of our data. We have 3 numbers on either side. When we look at this second set of data, we can see that there are actually 2 numbers that are in the middle. When that happens, we have to find the mean of those 2 values. So for this particular problem, we're going to have to add 8 plus 10, so the sum of those 2 values, divided by the number of values that are being considered, which is only 2. 8 plus 10 will give me 18 divided by 2, and that is 9. So our median for that second set of data would be 9. Now let's go ahead and discuss how we know whether I should use the mean or the median in order to describe the measure of center for a particular set of data. And in order to do that, we have to consider the data distribution or the shape of a graph. When we're looking at data distribution, there are 3 common ones that we see. We see skewed right, which happens when the mean is greater than the median. We see skewed left, that is when the mean is less than the median. And then we also see data that is symmetric. That is when our mean and our median are equal to each other. Now, whenever our data is skewed, whether it is skewed right or if it is skewed left, the median is the better measure of center. That is true because the median is not easily impacted by very small or very large values that are included in our data set, whereas the mean is easily influenced by those numbers. So again, whenever our data is skewed, whether it is skewed right or skewed left, the median is the better measure of center. When that is the case, when we're going to use the median to describe the measure of center for a data set, we can also discuss what we call the spread or variability of the data. And in order to do this, we consider the interquartile range, or the IQR. That simply means the range between the quartiles. So that 5-number summary that we discussed we would use for the creation of a box and whisker plot, we subtract quartile 3 minus quartile 1. And that gives us the range of the middle 50% of the data. And again, we want to use the IQR to discuss spread or variability when the median is the best measure of center. So when our data is skewed, whether it is skewed right or skewed left. Let's take a look at this in the context of an example. So we're going to take a look at this box and whisker plot, which represents home runs for York High School varsity baseball. And there are 12 batters here. By looking at this data display, by looking at this box and whisker plot, we can see that the data is skewed right. I know that because this whisker over here to the right is significantly longer than the whisker on the left. So I know that my data is being skewed right, which means that the IQR, or the interquartile range, would be the best to discuss the spread of the data. So in order to do that, we're going to write our IQR, which is quartile 3. So looking at my box and whisker plot, we can look at quartile 3, which falls at 24, minus quartile 1, which falls at 10. So 14 is the spread of my set of data here. Thank you so much for watching, and be sure to watch videos 2 and 3 for this lesson.